Hello student. Now we will discuss coefficient of self-induction. First, self-induction, the phenomena according to which an induced EMF is produced in a coil when current flowing through it changes with time is called self-induction. And coefficient of self-induction, suppose this is a coil L and current capital I is flowing through it. We know that magnetic flux phi, this is a magnetic flux phi linked with the coil. The magnetic flux phi links with the coil is directly proportional to the current capital I flowing through it. Mathematically, phi is directly proportional to capital I, or phi is equal to capital L into capital I. Let it be equation number 1. Here capital L is constant of proportionality and is called coefficient of self-induction. If unit current is flowing through the coil, that is capital I is equal to 1 ampere, then from equation number 1, phi is equal to L into 1 or phi is equal to L, or capital L is equal to phi, the magnetic flux linked with the coil. Let it be equation number 2, that is coefficient of self-induction is numerically equal to the magnetic flux linked with the coil when unit current is flowing through it. That is, if unit current is flowing through the coil, the magnetic flux induced in the coil links with the coil is equal to the coefficient of self-induction. If current capital I flowing through the coil changes with time, an induced EMF capital E is produced in it, which opposes the change in current through it. The magnitude of induced EMF produced in a coil is directly proportional to the rate of change of current flowing through it. Mathematically, E proportional to di by dt implies capital E is equal to minus capital L into di by dt. Let it be equation number 3. Here negative signs show that the induced EMF is opposite to the change in current, that is L, and L is constant of proportionality and is called coefficient of self-induction. If current flowing through the coil changes by unit rate, that is di by dt is equal to 1 ampere per second, then from equation 3, numerical value of induced EMF and is given by capital E is equal to L into 1, or E is equal to L, as L into 1 is L, or L is equal to capital E. Let it be equation number 4. Therefore, coefficient of self-induction is numerically equal to the induced EMF produced in the coil when current flowing through it changes by unit rate. This is the second definition of coefficient of self-induction. Now, units of coefficient of self-induction. In SI system of units, the units of coefficient of self-induction is Henry, capital H. From equation 1, phi is equal to L into 1, or L is equal to phi upon capital I. If phi is equal to 1 Weber and capital I is equal to 1 ampere, then L is equal to 1 Weber upon 1 ampere is equal to 1 Henry, capital H. Therefore, the coefficient of self-induction of a coil is 1 Henry if magnetic flux of 1 Weber induced in the coil when 1 ampere current is passed through it. So this is the definition of 1 Henry. Now second definition, from equation 3, E is equal to numerically L into di by dt, or implies L is equal to E upon di by dt. If E is equal to 1 volt and di by dt is equal to 1 ampere per second, then L is equal to 1 volt upon 1 ampere per second is equal to 1 Henry. Therefore, the coefficient of self-induction of the coil is 1 Henry if 1 volt of induced EMF is produced in the coil when current flowing through it changes by unit rate. So this is the second definition of Henry, 1 Henry. So this is something about the induction coil and coefficient of self-induction. Thank you very much.